Hey guys, welcome to our Calc Final project. This is going to be done by myself and Kylie. So we decided to do the 2016 FRQ. It was number 2, and that problem reads, for t is greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine t squared over 2. The particle is at position x equals 2 at time t equals 4. So I'm going to be walking you through parts A and C, and Kylie's going to be walking you through parts B and D. The first thing I want to show you, this is just a visualization of that given equation, the v of t equals 1 plus 2 sine t squared over 2, and that's on the interval from 0 to 12. So for part A, at time t equals 4, is the particle speeding up or slowing down? The first thing we're going to do is we're going to look to that given equation, v of t equals 1 plus 2 sine t squared over 2, and we're going to be plugging in 4 for t. So if you put 4 for everywhere there's a t, so 1 plus 2 sine of 4 squared over 2, that's going to give you the velocity at time t equals 4 of the particle, and that's 2.979. The next thing we have to do is we have to take the derivative of that v of t equation. Personally, I would recommend doing so in your calculator by just doing the derivative function and plugging in 4 for t, and that'll give you the value. But if you wanted to do it by hand, this is how you would do it. So if you see here, you're going to find the derivative of 1, which is just 0, so that goes away, plus the derivative of 2 sine t squared over 2. The first thing that I would say you should do is I would let x equals t squared over 2. So you're finding the derivative of sine of x, which is cosine of x, and this is just going to help you to kind of make it easier on yourself. So at this point, you're looking for 2 times cosine x, and then you're going to want to do the chain rule. So you're doing cosine of x times the derivative of t squared over 2. And so in order to find the derivative of that t squared over 2, you're going to be using the quotient rule, which is going to give you eventually just t. So you have t times the cosine of t squared over 2. And you've got to remember from the very beginning of our equation, we are multiplying its 2 sine. So we're going to still have that 2 by the end of the equation. So v prime of t is 2t cosine t squared over 2. Again, I would recommend doing that in your calculator because you don't actually need the equation in order to solve this problem. You can just do v prime of 4 and you can get that value much more easily than doing this whole thing out. So why did we get v prime of t? That's because v prime of t is synonymous to saying a of t. So the derivative of the velocity is just the acceleration. So now that we know that equation for the acceleration, we're going to plug in 4. So that's going to give you 2 times 4 times the cosine of 4 squared over 2. And that value is negative 1.164. So now we're going to look at these two values. V of 4 equals 2.979. And a of 4 equals negative 1.164. Since the velocity is positive and the acceleration is a negative value, we can tell you that the particle is slowing down. So that's all for A.
For part B, the question asks us to find all times on the interval from 0 to 3 where the particle changes direction. To begin this problem, we must first insert our given equation for velocity, which is v of t equals 1 plus 2 sine of t squared over 2, into our graphing calculator for y1 and hit graph. Now, looking at the graph of v of t on the interval from 0 to 3, we are looking for where the graph crosses the x-axis, or in other words, where v of t equals 0. By using second trace and the 0 feature on the calculator, we can find where v of t equals 0. This occurs only once on the interval, at t equals 2.707. A particle changes direction where velocity changes sign, or the graph crosses the x-axis. Therefore, the particle changes direction only once at t equals 2.707 because the graph of v of t changes from positive to negative at this point.
Hey guys, so I'm going to be walking you through part C now. The question is find the position of the particle at time t equals 0. So the first thing we need to do is we need to go back and remember the given information at the start of the problem, which I've highlighted right here. So that's v of t equals 1 plus 2 sine t squared over 2. And then we're also told that x equals 2 at time t equals 4. X is referring to the position. So that's telling us that the position of the particle at time 4 is 2. So position is the antiderivative of velocity. So in order to figure out the position, we're going to be looking at the integral from 0 to 4 of v of t dt because we're given that second value, the position at 4. So what that means is that if you look here, we're looking for the position at time 0, but we're just going to make this little equation saying that position is equal to the integral of v of t dt, which is equal to the position at time 4 minus the position at time 0. So we're told the position at time 4 is 2. So in order to get p of 0, that's 2 minus the integral from 0 4 bt dt. So we're really quickly going to exit the PowerPoint, and I'm going to show you how you do that on your calculator. So you would open up and plug in that original equation, v of t equals 1 plus 2 sine t squared over 2. And then you would plug in 2 minus the integral of v of t dt, which y in this case is going to be in place of that p of 0. And so p of 0 would equal negative 3.815. So you would definitely need to use your calculator for this one. So yeah, the answer is that the position of the particle at time 0 is negative 3.815.
For part D, we are asked to find the total distance that the particle travels from time t equals 0 to time t equals 3. To solve this problem, we need to integrate the absolute value of the velocity function, v of t equals 1 plus 2 sine of t squared over 2, on the interval from 0 to 3. We are using absolute value because we need to account for the distance the particle traveled after it changed direction. We are finding the area under the curve, both above and below the x-axis. Because we are finding total distance, we are going to add, rather than subtract, the area below the x-axis. This is why we're using the absolute value sign when we are integrating. We can find the total distance on our graphing calculator by using Math 9 and plugging in the interval from 0 to 3 and our absolute value of v of t equation. This will give us a total distance of 5.301 on the interval from 0 to 3.